The moon, hanging silently in the night sky, is more than just a glowing beacon guiding our dreams. It's a riddle wrapped in enigma. What if I told you that this celestial companion, so familiar in its phases, holds secrets that defy not only our understanding but the very laws of science? From strange lights flickering on its surface to theories suggesting it might not even be a solid body, the moon is far from the lifeless rock we once believed it to be. In this video, we're diving into 20 of the most baffling lunar anomalies that continue to perplex scientists and space enthusiasts alike. Each one is a piece of a grand mystery waiting to be unraveled, and some may even challenge everything we thought we knew about our place in the cosmos. So prepare yourself for a journey teeming with intrigue and wonder as we uncover the hidden puzzles of our closest cosmic neighbor. Now turning to our first anomaly, we explore the fascinating and controversial hollow moon theory. This idea suggests that the moon might not be the solid body we assume it to be, but rather hollow or containing vast internal cavities. The origins of this theory can be traced back to the seismic experiments conducted during the Apollo missions. When astronauts intentionally crashed lunar modules onto the moon's surface, the resulting tremors caused something extraordinary. Scientists reported that the moon rang like a bell for prolonged periods, a phenomenon that has never been fully explained. This peculiar seismic activity challenges our understanding of the moon's internal structure, which is generally believed to resemble solid celestial bodies like Earth. If the moon were indeed hollow, it would defy all known theories of planetary formation, raising questions about its origin and purpose. Could the moon be more than just a natural satellite? This anomaly not only intrigues scientists but also feeds speculative theories about artificial engineering or extraterrestrial involvement, making it one of the most captivating enigmas in lunar history. Moving forward, we arrive at our second anomaly, the moon's perfect alignment with the sun during solar eclipses. From Earth, the moon and the sun appear to be the same size in the sky, a phenomenon that allows for the breathtaking spectacle of a total solar eclipse. This alignment is due to an extraordinary coincidence. The moon is about 400 times smaller than the sun, yet it is also roughly 400 times closer to Earth. This precise ratio results in the moon perfectly covering the sun's disk during an eclipse, leaving only the sun's radiant corona visible. The odds of such a perfect match occurring naturally are so improbable that some researchers and theorists have questioned whether it could be purely coincidental. If the moon were just slightly smaller or positioned a bit farther away, this alignment would not occur. Some have even suggested that this unique characteristic might hint at a broader, unknown purpose behind the moon's placement in Earth's orbit. Is it simply a natural fluke, or could there be a deliberate design at play? This alignment not only fuels countless theories but also raises profound questions about the forces that shape the Earth-Moon system. It is this blend of scientific wonder and mystery that solidifies the perfect solar eclipse alignment as one of the moon's most extraordinary anomalies. Now turning to our third anomaly, we explore the mysterious characteristics of lunar craters. At first glance, these craters might appear similar to those found on Earth or other celestial bodies, but a closer examination reveals something truly puzzling. Many of the moon's craters, regardless of their diameter, share an unusual trait: they are surprisingly shallow. Even large impact craters, spanning many miles in diameter, exhibit depths that seem disproportionate to their size. This defies expectations based on conventional geological models. On Earth, the greater the impact force, the deeper the crater, but the moon does not follow this rule. Scientists have proposed that this anomaly could indicate the presence of an unusually hard, possibly metallic layer just beneath the lunar surface. This theory gained traction after seismic studies conducted during the Apollo missions suggested that the moon might have a dense or even metallic interior below its crust. Such a composition could prevent impacting objects from penetrating deeply, resulting in craters that appear strangely shallow for their size. The implications of this are profound. If the Moon does indeed have a metallic subsurface, it could point to a unique geological history or even challenge existing theories of its formation. Could this metallic layer be a relic of a cataclysmic event in the Moon's past, or does it hint at something even more enigmatic? Whatever the cause, the shallow craters serve as yet another reminder that the Moon is far more complex and mysterious than we often assume. Moving forward, we arrive at the fourth anomaly, the perplexing age paradox of the Moon. When Apollo astronauts brought back lunar rock samples, scientists uncovered a startling discovery. Some of these rocks were dated to be approximately 4.4 billion years old, making them potentially older than the Earth itself, which is estimated to have formed around 4.5 billion years ago. This contradicts the widely accepted theory that the Moon was created from debris resulting from a massive collision between a Mars-sized object and the early Earth. If the Moon formed after this impact, how could it be older than our planet? This puzzling age discrepancy has left researchers searching for alternative explanations. One theory suggests that the Moon might have originated elsewhere in the solar system and was later captured by Earth's gravity. Another, more speculative idea proposes that the Moon's ancient formation could be linked to panspermia, a hypothesis that suggests life and planetary building blocks might travel through space via meteoroids or comets. And then there are theories that delve into even more unconventional territory, hinting at the possibility of extraterrestrial influence or unknown processes that predate our understanding of planetary science. While these ideas remain unproven, they highlight the profound enigma of the Moon's origins and challenge our understanding of the formation of celestial bodies in the solar system. The Moon's age paradox is a mystery that continues to intrigue scientists and stargazers alike, adding yet another layer to the Moon's enduring allure. Now turning to the fifth anomaly, we uncover the mysterious phenomenon of the Moon's light flashes, often referred to as transient lunar phenomena. These fleeting bursts of light have been reported by astronomers for centuries, with the earliest documented sightings dating back to the 1600s. Observers have described these occurrences as brief, luminous glows, often appearing in different locations on the lunar surface and sometimes lasting only seconds. Despite their seemingly random nature, these events have been recorded enough times to suggest that they are not mere optical illusions. Modern scientists have proposed several theories to explain these enigmatic flashes. One possibility is that they are caused by meteoroid impacts where the collision generates a bright but short-lived glow. Another explanation revolves around lunar outgassing, a process where gases trapped beneath the surface escape, creating a momentary sparkle as they interact with sunlight. However, neither theory fully accounts for the frequency and variety of these sightings. In recent years, dedicated lunar monitoring programs have been developed to track and study these flashes in greater detail, using advanced telescopes and imaging technologies to capture the elusive phenomenon. Yet for all the efforts, the exact cause of transient lunar phenomena remains unresolved, leaving both amateur and professional astronomers captivated by their elusive beauty. Now turning to the sixth anomaly, we delve into the peculiar characteristics of the Moon's orbit around Earth, which has perplexed scientists for generations. Unlike the nearly circular orbits of most moons in our solar system, the Moon follows an elliptical path, with its distance from Earth fluctuating significantly. At its closest, known as perigee, the Moon is approximately 226,000 miles away, while at its farthest, called apogee, it drifts to about 253,000 miles. This elliptical trajectory gives rise to phenomena like the supermoon, where the Moon appears unusually large and bright due to its proximity, but the irregularities do not end there. The Moon's orbit is also tilted by about 5 degrees relative to Earth's orbital plane, an oddity that disrupts the alignment needed for lunar and solar eclipses to occur more frequently. Scientists have long debated how this unusual orbit came to be. Traditional theories suggest the moon was formed from debris left behind after a colossal impact between Earth and a Mars-sized object billions of years ago. However, this explanation struggles to account for the precise tilt and eccentricity of the moon's orbit. One alternative hypothesis is that the moon was captured by Earth's gravity after forming elsewhere in the solar system. But this raises further questions about how such a large body could settle into such a stable yet irregular orbit without being flung away or crashing into Earth. These orbital peculiarities continue to challenge our understanding of celestial mechanics, leaving experts to ponder whether hidden factors or unknown events from the moon's distant past might hold the answers. Moving forward, we encounter the seventh anomaly, the enigmatic traces of a lunar atmosphere that challenge our conventional understanding of the moon. Unlike Earth, the moon lacks the gravity needed to hold onto a substantial atmosphere. Yet, scientists have detected faint traces of elements such as helium, hydrogen, neon, and even argon in the moon's exosphere, a thin layer of particles that barely qualifies as an atmosphere in traditional terms. This discovery raises intriguing questions. Where do these elements come from, and how do they persist in an environment where they should quickly escape into space? One explanation is that solar wind, the constant stream of charged particles emitted by the sun, may be implanting these elements onto the lunar surface, only for them to be temporarily released due to micrometeoroid impacts or other processes. Another theory involves radioactive decay within the moon itself, which could generate gases like radon and argon over time. However, both these ideas fail to fully account for the consistent presence of these elements. Adding to the mystery is the existence of water molecules recently found in shadowed lunar craters, suggesting processes we still do not fully understand. The presence of even this tenuous atmosphere challenges long-standing ideas about the moon as a dead, inert world and hints at complex, ongoing interactions between its surface and the surrounding environment. Could these findings point to unexplored geological or chemical activity, or is there an external factor at play that we have yet to discover? As scientists continue to study this fragile exosphere, the mystery of the lunar atmosphere deepens, urging us to rethink what we know about our celestial neighbor. Now turning to the eighth anomaly, we delve into the perplexing reports of strange structures on the moon, an enigma that has captivated both scientists and conspiracy theorists alike. Over the years, countless images and observations have hinted at peculiar formations on the lunar surface, ranging from dome-like shapes to towering spires and even rectangular or triangular patterns. While some of these structures, like the so-called shard or tower, appear in grainy photographs and videos, their existence has fueled heated debates. Are these simply illusions created by shadows and light interacting with the lunar terrain, or could they represent something far more extraordinary? Proponents of natural geological explanations suggest that these formations could be the result of ancient volcanic activity, meteorite impacts, or unique erosion processes on the moon's surface. However, other voices argue that the geometric precision of some of these shapes defies what we would expect from purely natural phenomena. Could they be the remnants of extraterrestrial structures, evidence of a past intelligent presence on the moon, or even artifacts left behind by an advanced civilization? Skeptics often point to the limitations of low-resolution imagery and the human tendency to perceive familiar patterns known as pareidolia as the source of these claims. Yet, the lack of definitive studies leaves the door open to speculation. As lunar exploration advances and high-definition imaging becomes more accessible, these mysterious structures remain a topic of intrigue, challenging us to discern fact from fiction. What are we truly looking at when we gaze upon these enigmatic formations? Could conclusive answers lie just beyond our current technological grasp? With each new image and discovery, we edge closer to unraveling the truth behind these lunar mysteries, keeping the possibility of the extraordinary alive in the minds of many. Now turning to the ninth anomaly, we encounter the baffling mystery of the Moon's magnetic field, or rather, its strange and inconsistent presence. Unlike Earth, which has a powerful and well-structured magnetic field generated by its molten core, the Moon's magnetic field is incredibly weak and fragmented, almost like faint echoes of something that once was. This peculiarity raises profound questions. How can a celestial body with no active core to sustain magnetic activity still display localized magnetic fields in certain areas? Studies of lunar rocks brought back by Apollo missions revealed traces of magnetism, suggesting that billions of years ago, the Moon may have once had a much stronger magnetic field. But here's the twist: traditional models of planetary geology struggle to explain how the Moon could have sustained the necessary conditions for such a field in its early history. Some scientists speculate that an ancient dynamo effect created by the Moon's molten core spinning rapidly could have been responsible. However, evidence of a molten core phase on the Moon remains inconclusive. Others propose that intense cosmic events, such as massive asteroid impacts, could have temporarily induced magnetic properties in the lunar surface. Yet, even with these theories, the fragmented and patchy nature of the Moon's current magnetic field remains an enigma. Could this anomaly point to unknown processes in planetary formation? Or is it evidence of past events or interactions with external forces that we have yet to understand? The mystery deepens when we consider that the Moon's surface contains areas rich in magnetic strength known as magnetic anomalies, like those found around the lunar South Pole's Mare Ingenii region. These areas seem to defy the expectations of a body without a functioning magnetic core. Is it possible that these magnetic remnants are clues to a chapter in the Moon's story that has been lost to time? As we continue to study this phenomenon with more advanced instruments and methodologies, the answers we uncover might not only reshape our understanding of the Moon, but also provide new insights into the broader mechanics of our solar system's history. Moving forward, the Moon's magnetic field anomaly invites us to look deeper into its hidden past, leaving no stone unturned in the search for answers. Moving forward, the 10th anomaly we examine takes us to the dark and mysterious plains of the Lunar Maria, which cover a significant portion of the Moon's surface. These vast, dark regions, visible even from Earth, are not the result of shadows or simple surface discoloration, but are instead expansive basaltic plains formed by ancient volcanic activity. What makes these plains so intriguing is their sheer scale and distribution, raising questions about the Moon's fiery past. Studies of Lunar Maria suggest that billions of years ago, massive lava flows erupted and spread across the surface, creating these dark, hardened plains we see today. But here's where the mystery deepens. Modern observations show no signs of volcanic activity on the Moon, and its relatively small size and lack of atmosphere make it an unlikely candidate for the kind of tectonic forces that drive volcanic eruptions. So how could a body like the Moon have sustained the heat and energy required for such large-scale volcanic events? One theory proposes that the Moon's early formation involved a molten state, with radioactive elements in its interior generating enough heat to power volcanic eruptions. However, another puzzling aspect is the time frame. Most of the Lunar Maria formed during a relatively narrow period in the Moon's history, roughly 3 to 4 billion years ago, and then abruptly stopped. What caused such intense volcanic activity to begin and then halt so suddenly? Could external forces such as asteroid impacts have played a role in triggering these eruptions, or is there a missing piece in our understanding of the Moon's early geology? Additionally, the composition of the basaltic material found in the Maria raises further questions. These rocks contain unusual levels of elements like titanium, suggesting a unique and complex internal chemistry that challenges existing models of lunar formation. As we analyze these basaltic plains in greater detail using modern instruments, such as those on orbiting lunar probes, we may uncover answers that not only solve the mystery of the lunar maria, but also reshape our understanding of volcanic processes on rocky planets and moons throughout the solar system. From these plains, the moon's surface tells a story of dramatic and ancient events, inviting us to unravel the forces that shaped its unique landscape. As the next challenge unfolds, we delve into the 11th anomaly, unexplained moonquakes. Unlike the earthquakes we experience on Earth, moonquakes are far less understood but are no less intriguing. These seismic events occur deep within the lunar interior and happen sporadically, baffling scientists who study them. The phenomenon was first detected during the Apollo missions when astronauts placed seismometers on the moon's surface, revealing an unexpected level of seismic activity. What makes moonquakes particularly puzzling is their intensity and duration. Some of these tremors last for more than 10 minutes, far longer than typical earthquakes, and generate enough force to pose potential risks for future lunar bases. Now, this raises an important question. What could be causing these quakes on a celestial body that lacks the tectonic plate activity that drives earthquakes on Earth? One hypothesis suggests that moonquakes might be the result of gravitational interactions between the Earth and the Moon. As the Moon orbits Earth, tidal forces exert pressure on its interior, potentially triggering these seismic events. Another theory hints at the possibility of the Moon's crust shifting and settling over time, as it continues to cool and contract from its initial molten state. However, there are also moonquakes that originate deeper within the Moon, known as deep moonquakes, and these remain a particularly mysterious subset of the phenomenon. Some researchers speculate that they could be linked to pockets of activity within the Moon's core or mantle, but definitive evidence is still lacking. Adding to the intrigue, certain moonquakes have been observed to coincide with meteorite impacts, suggesting that external forces could also play a role. Yet, many of these quakes do not align with such impacts, leaving their origins a mystery. To further complicate matters, the Moon's seismic activity is not evenly distributed, with some regions experiencing more frequent or stronger quakes than others. This uneven pattern raises questions about whether there are structural differences in the Moon's subsurface or if some unknown factors are at play. The study of moonquakes is still in its infancy, and with advanced instruments on modern lunar missions, we may get closer to understanding this anomaly. Could these quakes hold clues about the Moon's internal structure, its geological history, or even its connection to Earth? As scientists continue to analyze data and develop new theories, moonquakes remain a fascinating reminder of how much we have yet to learn about our closest celestial neighbor. Moving forward, the next enigma awaiting exploration takes us deeper into the precise and uncanny geometry of the Earth-Moon system itself, where more mysteries are hidden in plain sight. With the next phase of the journey in sight, we uncover the 12th anomaly, what many call the Moon's geometric perfection. One of the most astonishing aspects of the Earth-Moon relationship is the extraordinary precision in the ratio between the Moon's diameter and its distance from Earth relative to the Sun. To put it simply, the Moon is about 400 times smaller than the Sun, yet it is also roughly 400 times closer to Earth. This uncanny balance allows the Moon to perfectly cover the Sun during a total solar eclipse, leaving only the Sun's ethereal corona visible. Such precision feels almost intentional, sparking debates that range from celestial coincidence to cosmic design. To understand the magnitude of this anomaly, it's important to consider how rare it is. Among the countless moons in our solar system, none exhibit an alignment remotely similar to that of our Moon. This unique phenomenon has not only fascinated scientists, but has also played a significant role in humanity's ability to study the universe. For instance, total solar eclipses allowed early astronomers to discover the sun's outer atmosphere and provided insights into solar activity that would have otherwise been impossible to observe. Some researchers argue that this alignment is just a natural result of gravitational dynamics and orbital mechanics, while others suggest that its precision defies statistical probability. Theories that lean toward cosmic design suggest that this impossible coincidence could hint at an underlying purpose behind the Earth-Moon system's configuration, though these ideas remain highly speculative. Adding to the intrigue, the current alignment is not permanent. The Moon is slowly drifting away from Earth at a rate of about 1.5 inches per year. This means that in the distant future, total solar eclipses as we know them will no longer occur, making this alignment a fleeting yet extraordinary spectacle in cosmic history. Could this fleeting precision be a mere quirk of the universe, or is it a puzzle piece to a larger, yet to be understood cosmic design? As we ponder this enigma, the Moon continues to challenge and inspire us with its mysteries. And speaking of mysteries, the journey now leads us to examine the unusual glass beads found on the lunar surface, unlocking another layer of the Moon's intriguing story. Now turning to the next fascinating mystery, we explore the peculiar discovery of tiny glass beads scattered across the lunar surface. These small, spherical formations are not simply a curious geological feature. They tell a story of high-energy events that have shaped the Moon's ancient past. Scientists believe these glass beads were formed as a result of intense heat generated during meteorite impacts. When meteoroids slammed into the Moon's surface at incredible speeds, the immense energy from the collisions melted the lunar soil. This molten material was then rapidly cooled, solidifying into glassy spheres. What makes this find particularly intriguing is the sheer abundance of these beads. Their widespread presence suggests that the Moon has endured an extraordinary history of bombardments far more severe than previously thought. Considering the lack of an atmosphere on the Moon to shield it from incoming meteoroids, it is understandable that impacts would be common. However, the sheer volume of these glass fragments raises questions about the scale and frequency of these ancient collisions. Did the Moon face an exceptionally violent period in our solar system's history, or do these beads hint at phenomena beyond conventional explanations? Adding to the puzzle, some of these glass beads have an unusual composition, containing elements that seem to hint at highly energetic and unique impact processes. This has led researchers to wonder if some impacts might have involved solar or cosmic events beyond the ordinary meteorite strikes. Could these beads be evidence of interactions with solar flares, distant supernova, or even past asteroid showers that swept through our corner of the cosmos? Moreover, these tiny formations serve as a natural archive, preserving a record of the Moon's turbulent past. By analyzing the chemical and isotopic makeup of these beads, scientists can piece together clues about the Moon's surface environment, the nature of the impacting objects, and even the history of solar and cosmic radiation. As research continues, these glassy remnants offer a glimpse into a chapter of cosmic history that remains largely unwritten. It's remarkable to think that something as small as a bead can carry such profound implications about the Moon's past and perhaps even the history of our broader solar system. What other secrets might these lunar artifacts reveal as technology advances and our understanding deepens? As we reflect on this microscopic yet monumental mystery, the journey takes us further into the enigma of the Moon's far side, where stark differences in its landscape add another layer to the puzzle. Now turning to the Moon's far side, we encounter an enduring mystery that has puzzled scientists for decades. Unlike the familiar near side, which is dotted with vast, dark plains known as Lunar Maria, the far side presents an entirely different face. It is heavily cratered with almost no Maria, and its crust is significantly thicker. This striking asymmetry raises the question, why are the two sides of the Moon so dramatically different? Scientists have proposed several theories to explain this disparity. One leading idea suggests that the difference in crust thickness may date back to the Moon's formation. In the early days of our solar system, the Moon is believed to have been surrounded by a molten outer layer, commonly referred to as a magma ocean. During this time, the gravitational pull from Earth could have influenced the distribution of materials, causing the crust on the far side to become thicker as lighter elements floated to the surface. Another intriguing theory points to a massive impact event. Some researchers speculate that a colossal object might have collided with the Moon early in its history, reshaping the near side and thinning its crust. This could explain the smooth lunar maria that dominate the side we see from Earth, while leaving the far side untamed and rugged. If true, such an impact would have been a defining moment in the Moon's formation, leaving behind the stark differences we observe today. A newer hypothesis delves into the role of heat and radioactive elements. The near side of the Moon contains higher concentrations of heat-producing radioactive materials, which may have fueled volcanic activity and created the expansive maria. Meanwhile, the far side, with fewer of these elements, cooled more quickly and retained its ancient cratered surface. This theory ties the lunar mystery to the unique distribution of materials in the Moon's interior, offering yet another possible explanation for its uneven appearance. The Moon's far side also sparks interest for what it might reveal about lunar exploration. Since it is shielded from Earth's radio interference, it provides a pristine environment for radio astronomy, potentially unlocking insights into the early universe. Yet its rugged terrain and thick crust pose significant challenges for future missions, making it both a scientific treasure trove and a logistical hurdle. As we ponder the secrets hidden on the far side, this dichotomy between the Moon's two faces deepens our fascination with our celestial companion. Could these differences hold the key to understanding the forces that shape not only the Moon but also the early dynamics of our solar system? With this question in mind, we move forward to explore a resource on the Moon that has revolutionized our understanding of its environment, the surprising discovery of water. Moving forward, we arrive at one of the most groundbreaking discoveries in recent lunar science, the presence of water on the Moon. For decades, the Moon was thought to be completely dry, an arid wasteland with no trace of water. However, over the last few decades, numerous missions and studies have overturned this assumption, revealing water molecules scattered across the lunar surface and concentrated in the shadowed craters near the poles. These craters are among the coldest places in our solar system, with some areas remaining permanently shrouded in darkness, creating a perfect trap for ice to persist over millions, if not billions, of years. The discovery of water on the Moon has profound implications for the future of space exploration. Water is an essential resource, not only for sustaining human life but also for producing fuel. By splitting water into hydrogen and oxygen, future lunar missions could generate rocket fuel directly on the Moon, potentially transforming it into a critical hub for deeper space exploration. Imagine a future where lunar water serves as the foundation for human colonies or as a refueling station for missions to Mars and beyond. The Moon, once thought to be a barren rock, could hold the key to humanity's expansion into the cosmos. What makes this discovery even more fascinating is the mystery of how water has survived the Moon's harsh conditions. Without a significant atmosphere to protect it, the Moon is constantly bombarded by solar radiation, which should evaporate or destroy exposed water molecules. Researchers are still working to understand the mechanisms that allow water to persist under such extreme circumstances. One theory suggests that water could be continuously replenished by comets and asteroids delivering ice during impact. Another proposes that solar wind could be interacting with the Moon's surface, creating water molecules from hydrogen ions and oxygen present in lunar minerals. Additionally, this water is not just sitting in pools or rivers as we experience on Earth. It exists in tiny quantities, often trapped within the soil or bound to minerals in the regolith, the moon's loose, rocky surface layer. Extracting this water will require innovative technology and methods, presenting yet another challenge for future explorers. Despite these hurdles, the potential rewards are enormous, with scientists and engineers already developing ways to mine and utilize this vital resource. As we continue to uncover the secrets of lunar water, new questions emerge. How much water is there really? Was it always present, or was it delivered during later stages of the moon's history? And perhaps most importantly, how can we harness this resource to make the dream of sustainable lunar exploration a reality? With these questions inspiring ongoing research, we now shift our focus to another fascinating aspect of the moon, its synchronized rotation, a phenomenon that ensures we only ever see one side. With the next phase of the journey in sight, we delve into an extraordinary characteristic of our celestial neighbor, its synchronized rotation, also known as tidal locking. This fascinating phenomenon is the reason why we always see the same side of the moon from Earth, with the far side remaining hidden from our direct view. At first glance, this might seem like a mere coincidence, but the process behind it is both intricate and captivating. Tidal locking occurs due to gravitational interactions between the Earth and the Moon. Over billions of years, these forces caused the Moon's rotation to slow down until it reached a point where its rotation period matched its orbit around Earth. In simpler terms, the Moon takes the same amount of time to complete one spin on its axis as it does to complete one orbit around our planet. This synchronization creates the illusion that the Moon isn't rotating when viewed from Earth, even though it is. What makes this even more intriguing is the question of how this synchronization came about. Scientists believe that in its early history, the Moon rotated much faster, but Earth's gravitational pull created tidal bulges on the Moon's surface. These bulges acted like brakes, gradually slowing the Moon's rotation over millions of years until it achieved the perfect balance we observe today. The astonishing precision of this balance leads some to wonder if it is purely a natural outcome of physics or if there could be more to the story. While mainstream science attributes tidal locking to well-understood physical processes, it's worth noting how this unique alignment continues to inspire curiosity and alternative interpretations. The significance of tidal locking extends far beyond its mechanics. This alignment has likely influenced the Moon's long-term stability, shaping its geological evolution and even its role in Earth's ecosystem. The constant interaction between the Earth and the near side of the Moon has impacted everything from ocean tides to the way life on Earth has adapted to the lunar cycle. Furthermore, the far side, which has been shielded from Earth's direct influence, presents a strikingly different landscape, offering clues about the Moon's formation and history. Scientists have used this difference to hypothesize about impacts, volcanic activity, and even the distribution of resources across the lunar surface. But questions still linger. Could the far side of the Moon hold secrets that the near side does not? Is tidal locking a common phenomenon among other celestial bodies, or is the Earth-Moon system uniquely special? And if so, what does that say about the forces that govern our solar system? These are the mysteries that continue to captivate astronomers as they look deeper into the cosmos. With this extraordinary synchronization in mind, we now pivot to another captivating topic: the mysterious signals that some believe have been emanating from the Moon itself. Now turning to the mysterious signals that some claim have been emanating from the Moon, we enter a realm of speculation, curiosity, and scientific intrigue. Reports of unusual radio signals originating from the Moon date back decades, with some of the earliest accounts coming from amateur astronomers who detected inexplicable frequencies while scanning the lunar surface. These signals, though faint and sporadic, have sparked a wave of debates and investigations, leaving many to question their origins. Could they be natural phenomena, the result of geological or atmospheric processes on the Moon? or do they suggest something far more perplexing, perhaps even pointing to intelligent activity? One possible explanation for these signals lies in the idea of natural radio emissions. The Moon, though lacking a substantial atmosphere, could still generate radio waves through interactions between its surface and surrounding cosmic radiation. These emissions might also be linked to solar activity, such as charged particles from the Sun interacting with materials on the Moon's surface, creating transient radio signals. However, the irregular and unpredictable nature of these signals makes it challenging to categorize them solely as natural phenomena. Another theory delves into the possibility of subsurface activity. Although the Moon is often regarded as geologically inactive, the presence of moonquakes and other anomalies suggests there could be dynamic processes occurring beneath its surface. These processes might produce electromagnetic disturbances, which could manifest as detectable radio signals. Scientists have also speculated about the role of lunar cavities or underground structures, possibly amplifying or channeling these emissions in ways we do not yet fully understand. But it is the alternative theories that truly capture the imagination. Some believe these signals could be artificial in origin, hinting at the presence of advanced technology either abandoned or still operational on the Moon. The idea of extraterrestrial involvement, while unproven, continues to fuel discussions among conspiracy theorists and researchers alike. Advocates of this theory often point to the consistent location and frequency characteristics of certain signals as evidence that they might not be random but rather intentional transmissions. What makes this enigma even more tantalizing is the lack of definitive answers. Despite modern advances in radio astronomy and lunar exploration, these signals remain an unsolved puzzle. Ongoing missions and studies aim to gather more data, hoping to untangle whether we are observing a natural lunar phenomenon, uncovering unknown geological processes, or possibly detecting something far beyond our current understanding. As we ponder the implications of these lunar signals, one cannot help but wonder, what else might we discover as we continue to explore the Moon? Could these signals be the first clue in unraveling a greater mystery about our celestial companion? With these questions in mind, let us move forward to consider one of the most extraordinary and controversial theories of all, the possibility that the Moon itself might not be as natural as it seems. Moving forward, we delve into the enigmatic xenomoon controversy, a historical puzzle that has left astronomers and historians alike scratching their heads. This controversy originates from ancient records that describe what appear to be additional moonlets visible in the sky centuries ago, celestial objects that modern observations fail to detect. These accounts, found in texts from diverse civilizations, often reference more than one moon-like body orbiting Earth, raising the question of whether our ancestors witnessed phenomena we no longer see today. One possibility is that these ancient descriptions could stem from misinterpretations of astronomical events. Bright planets like Venus or Jupiter, when viewed under certain atmospheric conditions, may have been mistaken for secondary moons. Similarly, rare celestial phenomena such as passing asteroids or comets could have created temporary illusions of multiple moons, embedding themselves in the folklore and historical records of the time. The lack of precise observational tools in ancient eras further complicates the reliability of these accounts, leaving room for natural explanations that align with known science. However, some argue that these records might reflect something far more intriguing. Could the moonlets described in these texts have been real, only to somehow disappear from Earth's orbit? While this idea may sound far-fetched, proponents of this theory suggest that gravitational interactions or catastrophic collisions with other celestial bodies could have caused these smaller objects to be ejected from orbit or obliterated entirely. This raises fascinating questions about the dynamic and potentially unstable history of Earth's immediate cosmic neighborhood. Adding another layer of mystery, some researchers have proposed that these moonlets might not have been natural objects at all, but could instead have been artificial in nature. This controversial perspective ties into broader theories about extraterrestrial activity, suggesting that what ancient civilizations documented could involve temporary spacecraft or other structures positioned near Earth. While there is no concrete evidence to support these claims, the mere possibility keeps the debate alive among those fascinated by lunar and space anomalies. What makes the xenomoon controversy so compelling is the enduring sense of mystery that surrounds it. Despite centuries of advancements in astronomy, the question remains unanswered. Were these accounts merely products of human imagination and misunderstanding, or do they hint at a real and forgotten chapter in our planet's history? As we continue to uncover the secrets of space, perhaps we will one day resolve this perplexing puzzle. With that enigmatic thought lingering, let us now turn our attention to another strange and captivating feature of the moon, the curious behavior of lunar dust. Now turning to the peculiar lunar dust mystery, we encounter an anomaly that continues to perplex scientists and engineers alike. Lunar dust, often referred to as regolith, is far more than just a collection of tiny, lifeless particles. Its behavior under the moon's unique conditions defies many of the principles we take for granted here on Earth. One of its most baffling properties is its apparent ability to levitate above the surface. Imagine this: fine particles of dust, seemingly defying gravity, hover or skip across the moon's landscape, creating an almost otherworldly spectacle. This phenomenon, observed during multiple lunar missions, challenges our understanding of electrostatic forces and their role in a low-gravity environment. The leading explanation for this levitation points to the moon's interaction with solar radiation. Without a protective atmosphere, the moon is constantly bombarded by the solar wind, a stream of charged particles from the sun. This exposure can cause lunar dust to become electrically charged. On the moon's daylight side, ultraviolet radiation from the sun amplifies this effect, creating an electrostatic force strong enough to cause the charged particles to push away from the surface and rise. In shadowed regions, especially near the moon's poles, a different kind of magic seems to occur. Here, particles appear to respond to the buildup of static electricity generated by movements within the dust layer itself, adding yet another layer of complexity to this mystery. What makes lunar dust even more fascinating is its stubborn and abrasive nature. Each particle is irregularly shaped and coated in a layer of glassy material formed by relentless micrometeorite impact. This sharp, clingy texture allows the dust to attach to nearly anything, from spacesuit fabrics to sensitive instruments. During the Apollo missions, astronauts reported significant issues with controlling this invasive dust, which not only caused mechanical problems but also posed potential health risks. The combination of its levitation abilities and its adhesive properties makes lunar dust an incredibly unique and challenging substance. Yet, beyond the practical concerns, the mystery of lunar dust levitation opens the door to larger questions. Could similar electrostatic phenomena occur on other celestial bodies with little to no atmosphere? Understanding this behavior might not only improve future lunar missions, but also offer insights into the surface conditions of asteroids, moons, and even planets beyond our solar system. As scientists continue to study this enigmatic lunar feature, we inch closer to uncovering the secrets locked within these tiny but extraordinary particles. With this intriguing puzzle in mind, let us continue our journey by examining the grand and audacious idea that some believe the moon itself could be an artificial spacecraft. With the next phase of the journey in sight, we arrive at one of the most controversial and captivating theories in lunar lore, the idea that the moon itself could be an artificial spacecraft. This notion, often dismissed as pseudoscience, first gained traction in the mid-20th century, thanks to a provocative hypothesis put forth by two Soviet scientists, Michael Vassin and Alexander Asecherbakov. They proposed that the moon might not be a natural celestial body at all, but rather a hollow, mechanical structure created by an advanced extraterrestrial civilization. Their theory suggested that the moon's outer shell could be composed of a protective layer of natural materials, camouflaging the artificial construct beneath. Supporters of this concept point to several unusual features of the moon as evidence. For instance, they argue that its precise orbital characteristics, such as its perfect synchronization with Earth that results in the same side always facing us, could be a deliberate design rather than a cosmic coincidence. Additionally, the theory often references the moon's apparent density anomaly. It is noted that the moon has a lower density than Earth, which some proponents interpret as a sign of an internal void or hollow structure. Further fueling this speculation are anomalies observed during seismic experiments conducted during the Apollo era. When lunar modules were crashed onto the moon's surface, seismic instruments recorded reverberations lasting for extended periods, leading some to describe the moon as ringing like a bell. While scientists attribute this phenomenon to the unique geologic composition of the moon's crust and mantle, theorists argue it hints at a hollow interior. Adding to the intrigue, advocates of the spacecraft theory often point to peculiar surface features, such as unconventional geometric formations and reported structures that some claim could be remnants of ancient alien engineering. Despite no concrete evidence supporting these claims, the idea persists in popular culture, often amplified by science fiction and speculative media. However, it is crucial to approach this theory with a discerning eye. Mainstream scientists dismiss the spacecraft hypothesis as unfounded, emphasizing the overwhelming geological and astronomical evidence that the moon is a natural satellite formed billions of years ago through processes consistent with planetary science. They highlight how seismic studies, density measurements, and the analysis of lunar rock samples all align with traditional models of lunar formation and evolution, leaving little room for such speculative ideas. Still, this theory captures the imagination because it raises profound questions about the origins and purpose of our celestial neighbor. Could the moon harbor secrets beyond those explained by conventional science? While the spacecraft theory remains unproven, it challenges us to think beyond established paradigms and continue exploring the mysteries of the universe with open minds. As we conclude our journey through these 20 unexplained lunar anomalies, one thing is clear: the moon holds countless secrets, some of which may never be fully understood. Now turning to a deeper exploration of the hollow moon theory, let's examine its implications for the moon's density and internal structure. The moon's density, measured at around 3.3 grams per cubic centimeter, is significantly lower than Earth's, which is 5.5 grams per cubic centimeter. This discrepancy has led some theorists to speculate that the moon's interior might not be entirely solid, suggesting the possibility of vast voids or even an artificial core. Proponents of the hollow moon theory often highlight that such a structural anomaly could not easily be explained by conventional models of planetary formation, where celestial bodies are expected to have a uniformly dense composition from core to crust. Perhaps one of the most intriguing pieces of evidence cited by supporters comes from seismic experiments conducted during the Apollo missions. When lunar modules were intentionally crashed onto the surface of the moon, the resulting impact caused reverberations recorded by seismometers left by astronauts. On one occasion during the Apollo 12 mission, the moon reportedly rang for over 55 minutes, likened to a bell by the scientists monitoring the data. This unusual vibrational pattern was observed again during subsequent missions, and while mainstream scientists attribute it to the lack of a water-saturated mantle and the moon's rigid geologic composition, theorists argue that it is suggestive of a hollow or metallic interior. NASA experiments provided more data that sparked debates among scientists and theorists alike. For instance, during Apollo 16, additional monitoring equipment detected a peculiar energy dissipation pattern, one that seemed inconsistent with purely natural geological processes. These findings continue to fuel conversations, even though most researchers interpret them as quirks of the moon's unique structure rather than evidence of an artificial construct. Critics of the hollow moon theory argue that these anomalies can be fully explained by established science. For example, the moon's relatively low density can be attributed to its lack of a substantial iron core, unlike Earth. Similarly, the long-lasting vibrations from the seismic experiments are thought to result from the moon's solid, brittle outer layers transmitting shock waves more efficiently than materials found on Earth. Additionally, the moon's composition, as revealed by rock samples, aligns closely with materials from Earth's upper mantle, lending credibility to the widely accepted giant impact hypothesis, which suggests that the moon formed from debris ejected during a colossal collision between a young Earth and a Mars-sized object. However, the hollow moon theory continues to captivate the imagination because it challenges traditional perspectives and invites us to consider alternative possibilities. Could the moon's peculiarities be a result of factors we have yet to understand? Is our closest celestial neighbor more than it appears? These questions remain open to interpretation, fueling both scientific inquiry and speculative thought. As we peel back the layers of these lunar mysteries, it is evident that even the most implausible theories have a unique way of expanding our curiosity and pushing the boundaries of what we think we know. This very curiosity is what drives us to explore the unknown, urging humanity to unravel the stories hidden within the cosmos. Moving forward, let's delve deeper into the fascinating phenomenon of transient lunar phenomena, those mysterious flashes of light that have been observed on the moon's surface for centuries. Reports of these fleeting illuminations date back as far as the 1600s, with astronomers documenting sporadic glimmers, glowing patches, and even colorful bursts over the lunar terrain. These events, unpredictable and elusive, have left scientists and enthusiasts alike searching for answers. What causes these enigmatic flashes? Are they natural occurrences, or do they point to something beyond our current understanding? One prominent theory attributes these flashes to meteorite impacts. The idea is simple. When a space rock strikes the moon's surface, the immense kinetic energy released upon impact generates heat, creating a brief but intense glow. This explanation aligns with our understanding of the moon's lack of an atmosphere, which leaves its surface exposed to frequent bombardment by meteors. However, there's a catch. Many of the reported flashes occur in regions where no fresh impact craters have been detected, raising doubts about whether meteorites alone can account for all these sightings. Another hypothesis centers around lunar outgassing, a process where gases trapped beneath the moon's surface escape into space. This could occur through small fissures or cracks in the crust, releasing bursts of gas that might briefly glow as they interact with solar radiation or create localized disturbances. While this theory is intriguing, evidence for significant outgassing on the moon remains scarce. The moon is not geologically active like Earth, making these gas escape events, if they happen, highly unusual and difficult to verify. Some have even suggested that the transient lights might be related to electrostatic phenomena. This theory posits that the moon's surface becomes electrically charged due to its interaction with solar wind, and under specific conditions, this charge could discharge as a visible flash. Yet, this proposal struggles to explain the wide variety of colors and intensities reported in the sightings, leaving gaps in its plausibility. These mainstream scientific ideas, while compelling, do not fully account for the patterns and characteristics of the transient lunar phenomena. And then there are the more speculative interpretations, which range from reflections off unidentified materials to even theories involving extraterrestrial activity. Though less grounded in evidence, these notions capture public imagination precisely because they entertain the possibility of the unknown. What complicates the mystery even further is the sporadic nature of these flashes, making them incredibly challenging to study. Modern efforts such as dedicated lunar observation programs and advanced telescopic monitoring aim to capture these events in real time to gather more data. Despite this, transient lunar phenomena remain as enigmatic as ever, challenging our understanding of the Moon's dynamic behavior. As we piece together these puzzling observations, it becomes clear that transient lunar phenomena are more than just fleeting glimmers in the night sky. They remind us of how much we have yet to uncover about our celestial companion, urging humanity to keep questioning, exploring, and reaching for answers that remain hidden in the Moon's shimmering light. And as we move to the next anomaly, the mysteries only deepen, with each discovery sparking even more questions. Now turning to the next anomaly, we dive deeper into the intriguing reports of strange structures on the Moon, focusing on some of the most famous examples that have fueled countless debates and speculation. Among these enigmatic formations are the so-called shard, the tower, and the castle names that evoke mystery and a sense of intentional design. The shard refers to a towering, spire-like object allegedly spotted by various observers in lunar photographs. Its sharp, angular appearance and considerable height make it stand out against the barren lunar landscape, leading some to question whether it could be a natural geological anomaly or the possible remnant of an artificial construction. The tower, another widely discussed formation, is said to resemble a column-like structure rising vertically from the Moon's surface. Advocates of its artificial origin argue that its symmetry and apparent height are too precise to be purely natural. Meanwhile, skeptics posit that it is nothing more than a trick of light, shadow, and perspective, with irregular rock formations giving the illusion of architectural design. Similarly, the castle, described as a complex of angular shapes and interconnected forms, has sparked numerous interpretations. Conspiracy theorists often frame it as evidence of extraterrestrial ruins or even a secret lunar base, while scientists urge caution, attributing its appearance to pixelation or other photographic artifacts. But how credible are these claims? Many of the images cited by proponents of lunar structures come from older, lower-resolution photographs, where shadows and distortions play tricks on the eye. Modern high-resolution imaging has attempted to revisit these sites, but definitive evidence supporting the existence of such formations remains elusive. Geological experts also contend that the unique conditions on the Moon, including its lack of atmosphere and history of meteorite bombardment, can create surface features that might appear unnatural to the untrained observer. Despite the lack of solid scientific backing, these purported structures continue to captivate imaginations worldwide. Those who believe in their artificial origins often point to the absence of plausible natural explanations as a reason to entertain alternative possibilities. Could these be remnants of ancient civilizations, evidence of extraterrestrial activity, or simply peculiar rock formations misinterpreted by eager minds? As with many lunar anomalies, the lack of definitive answers keeps the mystery alive. These structures serve as a tantalizing reminder of how little we truly know about the Moon and its history. Whether ultimately proven to be natural geological features or something more extraordinary, they inspire us to keep looking, questioning, and exploring. And as we shift to the next anomaly, the complexities of lunar mysteries only grow deeper, hinting at a wealth of secrets yet to be uncovered. With the next phase of the journey in sight, we delve deeper into the mysterious signals emanating from the Moon. These enigmatic transmissions, first reported by amateur radio enthusiasts and later investigated with more sophisticated equipment, have sparked endless curiosity and debate. Documented attempts to decode or trace their origins have revealed both tantalizing clues and perplexing dead ends. Some signals appear to exhibit a rhythmic or patterned nature, which has led to speculation about potential intelligent origins. Proponents of this theory argue that the distinct regularity of these signals could not be ascribed to natural phenomena alone, suggesting they might be the product of advanced, perhaps extraterrestrial technology. However, skeptics counter these claims by pointing to the possibility of otherworldly geological processes at work. The moon's unique environment, with its lack of a magnetic field and constant exposure to solar radiation, may create electromagnetic anomalies that we do not yet fully understand. Another line of inquiry considers whether these signals could emanate from subsurface activity, such as shifts in the moon's crust or interactions between buried material and solar winds. Complicating matters further, some researchers have noted that similar signals have occasionally been observed from other celestial bodies, including asteroids, hinting at a broader cosmic explanation rather than an isolated lunar phenomenon. Curiously, not all attempts to study these signals have been successful. In some cases, the transmissions seem to vanish before they can be fully captured and analyzed, leaving scientists and enthusiasts with fragmentary data that only deepens the mystery. Efforts to recreate the conditions under which the signals were first detected have yielded inconsistent results, fueling speculation that their appearance might depend on fleeting cosmic alignments or environmental factors. For those who lean towards the possibility of intelligent life, these inconsistencies are often cited as evidence of an evasive or deliberately concealed origin, though no conclusive proof has been found to support this claim. Still, the allure of these signals lies in their ambiguity. Whether they represent unknown natural phenomena or a signal from an intelligent source, they challenge our understanding of the moon and its role in the cosmos. As new technology emerges, perhaps future missions will succeed where past efforts have faltered, capturing clearer data and unlocking the true story behind these mysterious signals. From the hum of speculation to the silence of unanswered questions, this anomaly reminds us of the vast unknown that still surrounds our lunar companion. And as we look forward to the next anomaly, the inexplicable wonders of the moon continue to capture our collective imagination, each mystery drawing us deeper into the realm of the unexplained. As the sun rises on the next chapter, let's take a step back and reflect on the incredible journey through these 20 unexplained lunar anomalies. From the hollow moon theory to the mysterious light flashes, from strange signals to the moon's far side asymmetry, each anomaly has added a new layer of wonder and intrigue to our understanding of Earth's closest neighbor. These phenomena, whether rooted in complex science or shrouded in speculation, remind us just how little we truly know about the moon's origins, its nature, and its role in the greater cosmic puzzle. Each mystery serves not just as a question, but as an invitation to explore, to discover, and to imagine. While scientists continue to probe these anomalies with cutting-edge technology and evolving theories, one thing remains clear: the moon is far more than a barren, lifeless rock. It stands as a silent witness to both Earth's history and the broader story of our solar system, holding secrets that could redefine what we know about the universe and our place within it. Could the answers to these mysteries bring us closer to understanding life itself, or perhaps reveal connections to forces and phenomena we have yet to encounter? As we ponder the possibilities, we want to hear from you. Which of these lunar enigmas captured your imagination the most? What theories or ideas do you think hold the key to unraveling these cosmic secrets? Share your thoughts in the comments below, and don't forget to like this video and subscribe to our channel for more explorations into the mysteries of space. Together, we'll keep our eyes on the stars and continue the search for answers wherever they may lead. After all, the moon isn't just a light in the night sky, it's a gateway to understanding the infinite wonders of the cosmos.